Welcome back. Today we're going to be talking about secants and tangents. So we already talked about segments, the segment lengths dealing with two chords in a circle. Today it's going to be secants and some that have tangents. For two secants, before we start, we need to know our vocab for an exterior secant and a whole secant. So if I'm just looking at the exterior, I just want this guy right here. Now, if you remember, your secant touches your circle and it keeps on going. However, we can't find a length of something that doesn't stop, so we're gonna cut it off. It's just touching your circle 2 times, but it's gonna keep on going. If it just stopped right here at the A to B, that would be a chord. A secant, it's gonna keep on going, so it's gonna come out. Again, I have to be able to find the length of something that has endpoints. My exterior, this is the exterior portion of my secant, and then this is my whole secant. Now that's important for us because in order to find the lengths of two secants, you're going to multiply the exterior, the secant exterior, times the entire secant, and you're going to set that equal to the other exterior times the whole. So it would look like this. So I'm taking my EA, that's my exterior, and I'm multiplying it times EB, which is the whole thing. So the outside plus the inside, that entire length there. And I'm going to set that equal to the other exterior, which is EC, and that's this guy right here, times the whole secant, and that's going to be ED. Again, the outside plus the inside. So let's try one. Two secants, so I know I'm going through my circle and coming out. I'm going to take my exterior, which is my 3, and I'm going to multiply that by the entire length here. Now careful, I know a lot of you are going to want to say that that's 3x. It's not 3x. It's actually 3 plus x. So I'm going to add the outside plus the inside, and that's going to give me my whole. So my exterior is the 3, and the whole is the outside plus the inside, and that's where I get my 3 plus x. And that's going to be equal to this guy down here. My exterior is 4, and the whole thing is going to be the outside plus the inside, which is going to be 4 plus 2, or you could say 6. So now when I distribute, I'm going to multiply these guys, and I'm going to get 9 plus 3x, and that's going to be equal to 4 times 6, which is going to give me 24. Subtracting 9 from both sides, I get 3x is equal to 15, which means x is equal to 5. So that's when I have two secants, the exterior times the whole. And then when I have a tangent and a secant, remember your tangent just touches your circle 1 time and it usually goes on, but again, we can't take the length of something that doesn't stop, so we're just looking at this portion right here. That is my tangent, and then my secant is still this guy right here. With this, I'm going to do the secant follows the same rule, so I'm going to take my exterior times my whole. So this is my exterior right here, and this is my whole, the outside plus the inside, and I'm going to set that equal to whatever my tangent is squared. And this guy right here, EA, is my tangent. So it would look like this. My tangent portion, EA, whatever that length is, squared, is equal to EC times the entire length, which is ED. All right, so I'm going to take my tangent part squared, which is this guy. So I'm going to have my tangent squared, and that's going to be equal to my secant exterior, the part that's outside, which is 6 times the entire secant. And this is where I'm going to add my 2, outside plus inside. So I'm going to get 6 plus x. So now when I distribute this, I'm going to get 144 is equal to a 36 plus 6x. Subtracting 36 from both sides, I get 108 is equal to 6x, which means x is equal to 18. All right, so that's for two secants and a tangent and a secant. So now I just have practice problems. If you want to go ahead and pause it, this one's kind of challenging. It has to do with factoring. You're factoring with a coefficient other than 1 in the front, so if you want to pause and try to figure this one out, go ahead. Okay, so we're going to do our exterior. Our exterior is going to be x plus 1. And I'm going to multiply that by my entire secant. So the entire secant, I'm going to take the outside guy plus the inside guy. So I'm going to get x plus 1 plus x minus 1. And that's my whole secant. And I'm going to set that equal to the exterior of this guy, which is 3, times the whole thing. And I'm going to add my outside plus my inside. And I'm going to get 3 plus x plus 2. That's 2. Okay, so let's combine like terms. So I'm going to get x plus 1 times, and this positive 1, negative 1 is going to cancel, so I'm just left with 2x. And that's going to equal 3 times, and over here I'm going to get x plus 5. So now when I distribute here, I'm going to get 2x squared plus 2x, and that's equal to 3x plus 15. Now I want to move everything over to the left side. So I'm going to subtract 3x and subtract 15, minus 3x and minus 15. So it all moves over. And I have all of this equal to 0. So on the left side, I'm going to get 2x squared minus x minus 15. Now here you're going to have to factor. So this isn't the geometry, this is your algebra. You have to go back and remember how to factor this. We have a coefficient other than 1. So however you learn this, the bottoms up, the grouping, the guess and check, the box, whatever it is that you guys learned, I'm going to do grouping. So I want to know what numbers multiply to negative 30 and add to negative 1. And that's going to be a negative 6 and a positive 5. So I'm going to take these two terms and I'm going to replace my middle term here. So I'm going to get 2x squared minus 15 equals 0. But instead of my negative x, I'm going to rewrite it with these guys. So it's going to be negative 6x and a positive 5x. Because again, this is the exact same thing as saying negative x. I did that because I want to group these. From here, I want to factor out what can I take out of 2x squared minus 6x. I can pull out a 2x, which leaves me with x minus 3. And over here, what can I take out? That would be a 5, and that leaves me with x minus 3. That's what I want. I want my insides to be exactly the same. So now this factors to give me 2x plus 5, and x minus 3 is equal to 0. So from here, I'm going to have two equations. 2x plus 5 equals 0, and x minus 3 is equal to 0. So minus 5 from both sides. I get 2x is equal to negative 5 divided by 2. So x is equal to negative 5 halves. And over here, I'm going to add 3. So I get x is equal to positive 3. So these are my two possible answers. But again, I'm looking for lengths. So I have to check when I plug these back in, am I going to get negative lengths? Well, negative 5 halves is like saying negative 2.5. So negative 2.5 plus 1, that would still give me a negative length right here. And I can't have a negative length. So I know that this guy can't be an answer. So my answer is 3. A secant and a tangent. So I have my tangent out here. I'm going to take my tangent and I'm going to square him. So I'm going to get x squared, and that's equal to my exterior, which is 1, times the whole thing, which I'm going to take my outside plus my inside. And that's going to be 3 plus 1. So I get x squared is equal to 1 times 4, which means x squared is equal to 4 square root. So x is equal to a positive or negative 2, but I know a negative 2 won't work, so it's going to be a positive 2. All right, so on your homework tonight, you're going to have to work with a tangent and a secant. You're going to have to work with 2 secants, and you're going to have to go back and remember from previous lessons of 2 chords. All right, guys, so good luck. Let me know if you guys need any help.